Welcome, and thank you for participating in ground disturbance training. The fundamentals discussed in this course address the difference between ground disturbance, excavating, and trenching, the hazards associated with ground disturbance, and how to control these hazards through understanding how to manage and supervise ground disturbance, knowing what buried facilities are and the most common types, knowing soil types and control measures, understanding locate documents, markings, and the locate process, understanding the difference between a ground disturbance permit and crossing agreements, how to expose buried facilities and prevent damage, how to respond to utility strikes, and understanding backfilling and its process. The term ground disturbance refers to any of the following activities: cultivation to a depth of 45 centimeters or more below the surface of the ground, any activity to a depth of 30 centimeters or more, or any activity that reduces the cover of a utility to less than that utility's cover requirements. An excavation is simply a hole left in the ground as a result of removing material. And a trench is an excavation in which the depth exceeds the width. Common ground disturbance activities are not simply limited to the digging that we associate it with, but may also include ditching, tunneling, boring, drilling, pushing, augering, topsoil stripping, land leveling and grading, plowing to install underground, tree planting, clearing and stump removal, subsoiling, blasting and the use of explosives, quarrying, grinding, milling of asphalt or concrete, seismic exploration, driving posts, rods, pins, and so on, and piling. A vehicle crossing may be considered ground disturbance. This is the crossing of buried pipelines or other underground infrastructure by heavy loads off the traveled portion of a public roadway. When these conditions are met, you must first contact the facility, infrastructure, or utility owner. You must hand expose to confirm depth of cover, and you must use the ramps or cover specified by the owner. Ground disturbance work creates a variety of hazardous scenarios that pose a risk to both your health and your safety. Health hazards are typically created by striking buried utilities that can produce a hazardous atmosphere. Toxic atmospheres produced from materials such as decomposing organic matter or from gases that were trapped in buried, decommissioned facilities. And toxic atmospheres from the equipment doing the ground disturbance. Safety hazards are more numerous and more concerning because they are higher in likelihood. Common safety hazards include materials and equipment falling into the excavation, slips, trips, and falls as workers climb on and off equipment, falls as workers climb in and out of an excavation, tripping or falling over small equipment, tools, or excavated material, falling into the excavation from above, unloading pipe and other materials, handling and placing manholes, catch basins, vaults, and similar structures, handling and placing pipe and similar materials, and being struck by moving vehicles and equipment. A significant number of construction-related deaths and injuries reported each year in Ontario are directly related to trenching, most specifically those projects that have sewer and water main construction. Excavating and trenching fatalities are mainly caused by cave-ins. Death usually occurs by suffocation or crushing when a worker is buried by falling soil. When performing ground disturbance, we must also consider the environment. Many delicate ecosystems and environments are impacted when performing ground disturbance for buried facilities, such as bodies of water, natural habitats, wetlands, forested areas, sensitive soil areas, and existing soil contamination being displaced. After ground disturbance occurs, ensure the disturbed area is returned to its pre-construction state. It is your responsibility to ensure all necessary precautions are taken to protect delicate environmental areas. Supervisors have a responsibility to ensure that their documentation is in order for ground disturbance activities. This includes having your safe work practices and your safe job procedures in place, appropriate written approvals where required. All applicable regulations are understood and observed. Construction schedules and engineering plans must be available and accurate. Everyone has to have appropriate training certifications, and of course, locates must be accurate and on hand. Supervisors also have a duty to communicate critical information to the on-site team, such as placement of buried facilities within the ground disturbance area, how to support any exposed facilities, distances that must be maintained for mechanical excavation, inspection time frame and commitments prior to backfilling. The above may be communicated via your job hazard analysis, site meetings, safe work practices, safe job procedures, and tailgate talks. All communication methods must be exhausted to make sure you get it right. Training and retraining as often as required is crucial to prepare us for ground disturbance activities. All site staff directly involved in ground disturbance operations must be well trained. All site staff must be familiar too with equipment operation hand signals. Legislation is clear on how we must approach ground disturbance and that there's consequences if we don't follow those rules. Under the Occupational Health and Safety Act, a worker must not carry out any work or allow any other worker to carry out any work or operate any tools, appliance, or equipment if the worker believes that there may exist any danger to the health and safety of themselves or any other worker present on the worksite. If found guilty of an offense, you face substantial fines and penalties, including imprisonment for up to a term of 6 months, or both fines and imprisonment. When performing ground disturbance, we must expect to encounter buried utilities. A buried utility is anything below the surface of the ground used in the collection, storage, transmission, or distribution of water or stormwater, electrical, telephonic, telegraphic communication, cable or fiber optic services, electrical energy, oil, natural gas, steam, or chemicals. The most common types of buried facilities are pipes, conduits, manholes, service valves, ducts, cables, wires, catch basins, underground tanks, and building foundation. To perform ground disturbance safely, you must follow this process. In step 1, you have your pre-job planning. This includes knowing your company's ground disturbance protocols and understanding your responsibilities. Step 2 is searching the area. Plot the work area and search area and investigate all sources of information regarding buried facilities. Once you have determined the provider or owners of the buried facilities, you need to determine if external or internal approvals are required. The third step is notification, and this includes the compiling of proper notification documents and sending them to all buried facility owners and ensuring that you have the process in place to correctly receive the information. Step 4 in the process is locating and marking. This requires you to draw a proper plot plan and to ensure the job site and all lines within it have been located and marked with the correct color correspondence. These locates should always be double checked and rights of way should also be marked. Step 5 is exposure. This consists of ensuring that all the required on-site documentation is accessible and that proper safety precautions have been taken. You must understand hand exposure, site maintenance requirements, and how to deal with accidental damage to facilities. And step 6 involves inspections. This involves backfill requirements, backfilling inspections, and all required documentation. The locating and marking process usually involves contacting Ontario One Call. Ontario One Call is a service that allows contractors and underground facility owners to work together to prevent any damage to existing facilities. They are available 24/7 at 1-800-400-2255. And as per them, there are 5 steps to safe digging. Step 1 is contact Ontario One Call a minimum of 5 business days before you dig. Provide required information, including exposure method, whether it's hand exposure or mechanical. Step 2, wait for the utility and buried facility companies to mark, locate, or clear the outlined dig area. Step 3 is confirm all buried facility companies have responded to your requests and have marked the outlined dig area properly. Step 4 is to thoroughly inspect and review all color marks and locate package details to ensure safe digging. And step 5, of course, is to dig safe. Locates are ground markings identifying the position of utility lines based on records or electronic locating equipment and the associated necessary documentation, such as a locate sheet. Ground markings consist of different colors that are used to reflect each type of utility infrastructure, such as gas, hydro, and cable. Keep your locate document current and accessible. Paper copies are required in every piece of equipment that is performing ground disturbance. There are standards for locates, and that involves these locating and marking requirements. All buried facilities need to be marked by a professional locator. Once locates are completed, facility owners may need to inspect them. Locates can be marked with flags, stakes, or marking paint, but not just any material. Locates must be spaced no more than 5 meters apart and on curves so that the curve is clearly visible. Locates are valid for a period of 60 days in Ontario, and you have to have locators return as required. All professional locators use this utility location color code. Red stands for electrical power lines, cables, conduit, and lighting cables. Yellow represents gas, oil, steam, petroleum, or gaseous materials. Orange represents communication, cable TV, alarm or signal lines, cables, or conduit. Blue represents water, irrigation, and slurry lines. Green represents sewers and drain lines. Pink represents temporary survey markings. And white is the proposed excavation. We've discussed Ontario One Call as your primary information source for buried facilities, but there are many others that may need to be utilized, such as land titles, maps, plot plans, and as-builts, landowners, municipal and rural utility owners, private locates, company markers, area operations personnel, and regulatory bodies. If the owner of a buried facility is not registered with One Call Center, you are still required to contact them about the ground disturbance and request that they identify and mark the locations of the facilities. Part of your due diligence in ensuring your ground disturbance area is accurately marked is looking for visible indicators of buried facilities. Look for land variations such as depressions and scarring. Look for variations in the vegetation. There are above ground markers as the ones you see here. Look too for surface patches, structures of course, buildings, and a variety of different covers. When exposing buried facilities, you must use hand exposure. Hand exposure is a regulation put in place to ensure non-destructive excavation techniques are used to expose buried facilities prior to mechanical excavation. The permissible types of hand exposure or non-mechanical exposure are hydrovac excavation, suction excavation, and hand digging. Hydrovac excavation is the process by which high-pressure water is used to break up dirt and material. This material is then vacuumed up into a truck via hose and brought off-site to a proper disposal facility. This process can also be known as hydroexcavation, daylighting, potholing, or vacuum excavation. Using this method is a safer, more efficient, and non-destructive method of excavation than traditional manual or machine excavation. Suction excavation is the process by which high-pressure air is used to break up dirt and material. This material is then vacuumed up into a truck via hose and can be disposed of either on-site or a designated disposal site. This suction process without the use of water provides the safety, efficiency, and non-destructive benefits of hydrovac excavation with the additional benefit of being able to leave the materials on site due to the absence of water. Hand exposure begins at or near the locate marks or based on the dimensions from provided drawings. Work down and outward into the hand exposure zone until buried facilities are found. Note that the minimum additional depth to hand expose according to industry best practices is 300 millimeters or 1 foot, meaning you don't stop at the bottom of the discovered utility, you go on for another foot to ensure there are no other utilities below and that you have in fact located the correct depth of the bottom of the utility. Striking buried utilities can be deadly, and it is almost always very costly. Therefore, once again, it is important for buried facilities to be located by non-mechanical means. There is some variation to hand exposure rules based on the utility. Therefore, best practice is to follow the 1 meter rule. Excavators must hand dig within 1 meter from either side of the outside edge of the underground facility service. And if you need to trace the depth and exact location of the facility, dig test holes no more than 4.5 meters apart. During hand exposure, if you expose a hydro line that is not concrete encased or in conduits, you must notify the owner and request an outage. There are other do's and don'ts that must also be observed. First of all, don't probe with pointed tools. Don't use pickaxes or pointed bars, and never jump or use your entire body weight on the shovel. But do use blunt shovels if possible. If your shovel is spade-shaped, proceed with caution. Use a prying motion to loosen hand dirt rather than striking. Dig on an angle. Think glancing blow instead of direct hit. Hand exposure of buried facilities can occur in special circumstances. Frozen ground, concrete, asphalt are not exceptions to hand digging. You need to consult with the utility owner to determine whether heat can be applied and if utilities are encased. Then thaw frozen ground when approved, and cut hard surfaces with precise cutting depth and lift only when approved. To prevent damage to utilities, we need to understand why utility strikes occur. First off, many facilities are buried close to the surface within 3.5 feet, making them easily reached by mechanical excavations and susceptible to strikes. Other conditions that are an issue are lack of employee training, inadequate or no ground disturbance procedures, site drawings that are inaccurate or not up to date, failure to reference available sources, and failure to locate and check all lines within the work area. Outside of these conditions, worker error is also an issue. Contact with a utility can have catastrophic results such as sudden ruptures, fires, explosions, and release of toxic substances. No matter how minor the form of contact, you should inform the facility owner immediately for inspection to ensure safety. You must identify the strike damage, look for punctures or cracks, scratches or gouges, flattening or denting of the facility surface, and damage to protective coatings. If contact occurs, you need to manage the situation safely. Stop work immediately. Follow emergency response plans that are crafted in advance. Notify the site supervisor and management immediately. Secure the work site. Notify the facility owners and regulatory bodies. Notify them even if the damage has not disrupted the utility and appears superficial. Remember your emergency plan for hydro strikes. If you strike hydro, stay where you are. Another wrong move may result in a serious injury or fatality. The equipment and you may now be at the same electrical potential as the power source, and there may be a current flowing through the ground. Don't touch anything outside the equipment. You might create another path to the ground for the electrical current. Warn others to stay at least 10 meters away. Call the hydro company. Have someone call the utility to get help. Also, call 911 or the emergency responders in your area. If you must get out, only as a last resort. If you must get off the equipment due to fire or other hazards, you must do so without touching the equipment and the ground at the same time. Jump about 45 centimeters to 60 centimeters away from the equipment, landing with feet together and arms close to your body. Keep your feet together, touching, and shuffle at least 10 meters away. Your heels should never pass your toes. And then we must perform rescue. When a power line has fallen or has been damaged below ground, always consider it to be energized. Stay back at least 10 meters. Rescue can only be attempted safely by a person trained to use special live line tools. Never attempt a rescue if you are untrained. When contact occurs, you must report. The process to properly notify buried facility owners is simple but important. Once again, immediately notify facility owners and regulatory bodies. Provide the location of where the damage occurred and list the type and severity of the strike damage. Once notified, an incident report must be completed and retained by both parties. Investigation causes must be listed. Prevention actions must be implemented. These reports may be requested by investigative agencies and must be made available upon request. And ground disturbance activities cannot be started again without the approval of the facility owner. There are 4 soil types, each having distinct characteristics that define how they must be excavated. Now we will explore each soil type. Type 1 soils are hard, very dense, and only able to be penetrated with difficulty by a small, sharp object. Type 1 soils have a low natural moisture content and a high degree of internal strength. There are no signs of water seepage, and it can be excavated only by mechanical equipment. Well-established clays are examples of Type 1 soils, as are rock soils such as shale and solid bedrock. Type 2 soils are very stiff, dense, and can be penetrated with moderate difficulty by using that same small, sharp object. Type 2 soils have a low to medium natural moisture content and a medium degree of internal strength. Type 2 soils are damp in appearance after they are excavated. Many examples of type 2 soils exist. They are often a type of clay that is not well enough established to be considered a type 1. Type 3 soils are stiff to firm and compact to loose in consistency, or it's previously excavated soil. It exhibits signs of surface cracking. It exhibits signs of water seepage. If it is dry, it may run easily into a well-defined conical pile, and type 3 soils have a low degree of internal strength. Many examples of type 3 soils exist. They are often a type of clay that is not well established to be considered a type 2, or very well established topsoils with little to no plant growth. Type 4 soils are soft to very soft and very loose in consistency. They are very sensitive, and upon disturbance, they're significantly reduced in natural strength. Type 4 soils run easily or flows unless it is completely supported before excavating procedures. It has almost no internal strength. It's usually wet or muddy, and it exerts substantial fluid pressure on its supporting system. Granulars and sands are examples of type 4 soils. Controls must be implemented to address the risk of collapse. Sloping is a common control. The degree of sloping depends on the type of soil being excavated. For type 1 and type 2 soils, cut trench walls back at an angle of 1 to 1 or 45 degrees. That's 1 meter back for each meter up. Walls must be sloped to within 1.2 meters or 4 feet of the trench bottom. For type 3 soils, cut trench walls back at a gradient of 1 to 1 from the trench bottom. And for type 4 soils, slope the walls at 1 to 3, that's 3 meters back for every 1 meter up from the trench bottom. Another control option to address the risk of collapse is shoring. It is a system that supports trench walls to prevent movement of soil, underground utilities, roadways, and foundations. The two types of shoring most commonly used are timber and hydraulic. Both consist of posts, wales, struts, and sheathing. Whenever possible, shoring should be installed as excavation proceeds. If there is a delay between digging and shoring, no one must be allowed to enter the unprotected trench. All shoring systems must extend above the top of excavation by at least 300 millimeters. The third control option for addressing the risk of collapse is a trench box. Trench boxes are not usually intended to shore up or otherwise support trench walls. They are meant to protect workers in case of a cave-in. The space between the box and the trench wall should be backfilled. Otherwise, a cave-in or collapse may cause the trench box to tilt or turn over. It's also easier to enter the box if soil comes right up next to it. Trench boxes are commonly used in open areas away from utilities, roadways, and foundations. If you're in the trench box, stay inside the box. And just like shoring, trench boxes must extend above the top of an excavation by at least 300 millimeters. A necessary complement to the controls of shoring and trench boxes are ladders. Whether the trench is sloped, shored, or protected by a trench box, you need a way to climb in and out safely. Trenches must have ladders in the areas protected by shoring or trench boxes. The ladder must be securely tied off at the top. It must extend above the shoring or box by at least 900 millimeters or 3 feet, and be inspected regularly for damage. A ladder should be placed as close as possible to where you're working and never more than 7.5 meters or 25 feet away. When working in a sloped excavation or trench, it is preferable to cut in stairs or a gentle slope. This type of access and egress is safer and more practical than ladder use. A buffer is required above the excavation wall and beyond it to control the hazards of excavation collapse, materials and tools falling into the excavation, and to ensure safe access and egress. The spoils of an excavation cannot be cast or staged any closer than 1 meter from the edge of an excavation. This rule also applies to staging tools and materials. In some cases, we must also implement controls for people that are working around but are not part of the excavation operations. In the case of excavations in trenches that have depths exceeding 4 feet and are left unattended, they must be fenced off. In some other cases, working at heights legislation applies. With excavations in trenches that have depths exceeding 10 feet, they must be equipped with guardrails or have bump lines installed 2 meters from the edge. When sloping, shoring, or the use of a trench box is not practicable, a worker may enter the excavation or trench under 2 conditions. The first condition is if the excavation walls are certified as stable by an engineer. The second condition are if barriers are set up inside of the excavation that prevent workers from approaching the excavation wall any closer than the wall is high. In this example here, you will see how a barrier was set up no less than 2 meters from an excavation wall that is 2 meters high, thereby preventing workers from approaching the wall into unsafe areas. This system would need to be set up for multiple walls if the same scenario exists in the same excavation or trench. Hand signals play an important role in ensuring health and safety during ground disturbance operations when heavy equipment is involved. A failed hand signal can be catastrophic. It is therefore imperative that workers on the ground and operators in heavy equipment are on the same terms when it comes to hand signals. Take a minute to review and practice these hand signals. Backfilling is the action of refilling the excavation with the material which was removed from it or another in order to cover the facility again. Backfilling is ground disturbance as well. An important backfilling requirement is that you need to prove that you have made all reasonable efforts to have an inspection performed prior to backfilling. This means you are required to notify the buried facility owner that a backfilling inspection is required and provide the buried facility owner at least 24 hours notice prior to backfilling. In summary, ground disturbance is a challenging and heavily regulated activity because it poses many risks to health and safety. Planning is crucial in performing safe ground disturbance. Locates are the primary source of planning safety into your ground disturbance activities. Controls for excavation walls, exposure to heights, access and egress, protecting utilities, and working safely with heavy equipment must be planned for in advance, implemented immediately, and monitored. You have reached the conclusion of this course. Thank you for your participation in ground disturbance training. Please complete the test to conclude the course.